Many campers have reported being visited during the night by various intruders. Some of the campers were awake at the time of visitation, but others slept through the experience, only to find evidence of the intrusion when waking in the morning. This paper describes a simple cheap apparatus for detecting a campsite intruder and waking sleeping campers without alerting the intruder that it's being detected. The apparatus monitors the campsite's infrared background level and triggers silent tactile alarms when the infrared level changes rapidly enough. The particular alarms triggered indicate the position of the intruder in the campsite. Visible and audible alarms may also be easily added to the apparatus as desired. The basic components are 1. PIR, passive infrared, motion detectors. 2. Button-type vibrating motors. 3. Battery. 4. Cables and connectors. Total cost of components to accommodate one camper, except the battery, will likely be under $50, depending on component sources and the particular chosen apparatus configuration. Additional campers can be accommodated at a likely component cost of under $20 each. The detectors and motors specified in this example of the apparatus are from the sources noted below. They may be replaced with any functionally equivalent components. Theory of operation. Each PIR motion detector responds to changes in the infrared level in its field of view by switching its output voltage between 0 volts and the supply voltage. The output terminal of each detector is connected by wire to an associated alerting device, herein referred to as an alarm. In the stealthy version of the apparatus, each alarm is an assembly of one or more button-type vibrating motors in contact with a camper's body, which assembly can be configured to be inaudible to the intruder. Other alarms emitting light or sound may be added as desired, and detector outputs can provide logical triggers or supply power to other devices, depending on chosen power supply voltages. The active components of the apparatus are connected in a modular fashion by standard off-the-shelf RJ11 6P4C, 6-pin, 4-conductor, 4-wire telephone cables, of lengths chosen by the user for a given physical arrangement of the components, through standard off-the-shelf RJ11 6P4C connectors. This modularity allows flexibility in component arrangement and simplifies modification of the system by adding cables and connectors as needed. This example of the apparatus uses 3 detectors for a 360-degree field of view and a set of 3 alarms per camper, each alarm being associated with one of the detectors. The association of each alarm to a given detector provides a sense of direction of the intruder's presence and motion in the camp. The alarms may be incorporated into headgear worn by the campers while they sleep, to wake them if an intruder arrives. Alternatively, the alarm sets can be positioned on campers' legs, arms, torsos, and elsewhere. The detectors specified here have 180-degree fields of view, so a back-to-back pair of them would cover 360 degrees, except for a few inches dead zone on each side of the pair, but would not give the directional discrimination provided by the array of 3. A camper outside the tent, perhaps sitting by the campfire, or preparing food, or gathering firewood nearby, could be alerted if wearing the alarm set and connected to the apparatus by a long enough cable. An alternative arrangement would be to put a walkie-talkie in contact with a camper's alarm set inside a tent, to send an audible alarm to a walkie-talkie carried by the camper outside the tent. Similarly, a Bluetooth microphone could be paired with a headset or speaker for the same purpose. If the camper is sleeping in a vehicle instead of a tent, the fact that ordinary glass blocks the infrared sensed by the detectors should be kept in mind. Components. PIR detectors. These sense changes in their ambient infrared fields and switch their output voltages when those changes reach the thresholds set by their sensitivity adjustments. In this application, the outputs will provide power to button motors arranged to provide tactile input to a camper as a stealthy alert for the presence of an intruder. Note: a detector continuously adjusts its background infrared level, ignoring very slow changes of the infrared level in its field of view, even very large changes, and triggers only when a change is great enough and rapid enough. For instance, a sumo wrestler moving very slowly through the field of view will be considered to be a change in the detector's background level and pass unnoticed, but a sparrow flying past will trigger the detector. The detector model in this example was chosen for its features of low cost, sensitivity, field of view, adjustment options, and supply voltage adaptability. It is specified to work on a voltage of 12 volts DC, but was found to work normally on 5 volts. When triggered, this detector model connects its output wire to the supply voltage, minus about 0.5 volts. Other models may connect their output wires to 0 volts instead. This detector model is specified to detect a human body as far away as 40 feet. Since its sensitivity is directly related to the temperature difference between the background and the intruder, in a cold environment it could sense a large warm intruder at a much greater distance. False triggers from moving branches and marauding raccoons can be minimized by masking the top and bottom sections of the lenses. An unmasked gap of 1/4 inch across the middle of the lens is sufficient for detection of a large warm body moving through the field of view. This model will trigger continuously as long as it perceives motion, with no recovery time delay after each trigger. At power-up, PIR detectors automatically calibrate themselves to the existing background infrared level, during which time their outputs are active. This model typically takes about 20 seconds for that process. Button motors. These are designed to provide vibrations in cell phones operating in silent mode, versus ringing mode. They are a type of pancake motor with an eccentric weight added to cause the vibration. The higher the voltage supplied to the motor, the higher its rotation speed and thus the higher its vibration frequency. The motor model in this example is specified to work on a voltage of 1.5 or 3.0 volts DC, but was found to work normally within the range of 1 to 10 volts. It is possible to damage a motor by running it for too long on too high a voltage, in which case it will overheat and burn out. If it will be energized continuously for more than 30 seconds at a time, the highest safe voltage for this model is 6 volts. Several motors may be connected in series to divide the available supply voltage among them, to reduce overall power consumption, and to eliminate the risk of motor damage. The motors have colored wires, but the polarity of the applied voltage doesn't matter, as they rotate well in either direction. Battery. The detectors and motors in this example were tested on supply voltages ranging from 5 to 13 volts DC. Thus, several battery options are available, from USB 5-volt power packs, or even notebook PCs with USB ports, to 12-volt auto batteries. Depending on the number of alerts and the total power consumption by alarm components, a 9-volt battery, a 6-volt lantern battery, a 7.4-volt lithium-ion battery, or a USB power pack could supply power to the system for several days. Note, some USB power packs will turn off automatically if too little current is drawn from them for a given time. Construction. Detector array. In this example of the apparatus, the directional orientation of a detector corresponds to the left, right, or back side of a tent. The detectors are labeled L, R, and B respectively, as are the detector output voltages on the cables and connectors. The detectors are arranged so that their fields of view overlap. The overlap of the fields of view enhances their directionality, giving 6 discrete detection zones, as shown in Figure 1 below. For example, if both the left and right alarms are triggered, the intruder is in the L+R zone in front of the tent. To allow campers to be active in an area outside the tent without triggering alarms, the detector array can be placed on the opposite side of the tent from the active area, with the back detector facing the tent, so that the tent blocks the camper's motions from the detector, but any motion outside the tent's shadow will be detected. The case where the active area to be blocked from detection is in front of the tent is shown in figure 2 below. Of course, to maintain detector direction orientation, alarm headgear would be worn in reverse. In the preferred configuration, the 3 detectors are attached to a single upright pole or tube tall enough that the detectors can be positioned above the top of the tent. The upright must be stable enough to prevent movement of the detectors, to eliminate false triggers from detector motion. A standard camera tripod secured by bungee cords to a cinder block might suffice as the upright. The detectors may be arranged around the upright at 120-degree angles as in figure 3 below, or they may be stacked on the upright. Precise alignment of the detectors is not needed. Since the back halves of the detector cases are empty except for wires, holes may be drilled in their cases as needed for mounting, taking care to not damage the wires inside. To allow the detectors to be arranged around the upright at 120-degree angles, the positioning elements on the backs of their cases must be removed. Then the detectors may be held together with tape, glue, soldering iron welds, or zip ties passing through holes drilled in the sides of their cases. To allow the detectors to be stacked on the upright, holes must be drilled in the tops and bottoms of their cases, through which the upright is inserted. The blue wires of all detectors are soldered together, and the brown wires of all are likewise soldered together. The battery's positive, plus, terminal is connected to the brown wires and the battery's negative terminal is connected to the blue wires. Depending on the battery type used, alligator clip jumpers might suffice to connect it to the wires. If the battery is small enough, it can also be attached to the upright. Cable options. The detector's red wires are the output lines. A length of standard 4-wire telephone cable connects the detector outputs and the battery's negative terminal to the alarms through standard off-the-shelf RJ11-6P4C telephone cable connectors. This detector cable can be made by cutting the plug off of one end of a telephone cable and soldering the cable's wires to the corresponding detector wires. Although it would be preferable to make this cable long enough to reach into the tent, it does not need to be very long, as it can be extended by simply adding a coupler and another cable in line with the detector cable. Note, if the model of detector being used connects its output wire to 0 volts when triggered, instead of to the supply voltage, the black wire, pin 1, must be connected to the battery's positive, plus, terminal instead of its negative terminal. Conveniently, a standard cable can be cut in two to make both a detector cable and an alarm cable. The left-to-right order of the colors of the wires in a standard telephone cable is reversed, mirrored, in the plug at each end with respect to the other end. To ensure proper operation of the alarms, take care that the color order of each alarm cable mirrors the color order of the detector cable. An easy way to do this is to place the plugs on both cables side by side, or end to end, to verify that the color order in one plug is mirrored in the other plug. See the wiring diagram below. If only one set of alarms is being used, the detector cable would be plugged into the jack on one side of a coupler, and the cable to the alarm set would be plugged into the jack on the other side. An alarm cable can be extended by simply adding a coupler and another cable in line with the alarm cable. Extension cable color order is irrelevant. To connect two alarms, the detector cable could be plugged into the single jack on one side of a female to 2 female, F2F, splitter, and the two alarm cables would be plugged into the output jacks on the other side of the splitter. To connect additional alarms, the male, input, plug of a male to 2 female, M2F, splitter or male to 4 female, M4F, splitter would be plugged into the output jack of the coupler, and the cables to alarms would be plugged into the splitter's output jacks. The number of available output jacks for alarms can be multiplied by simply connecting splitters in series. Alarm sets. Options for alarm set assembly and configuration are so numerous that only one example will be described here. Most important is to assure the physical integrity of the motors. An alarm set of just one motor per detector works well if the supply voltage is 5 or 6 volts. If a 9-volt or 12-volt battery will power the system, each detector's alarm should be at least 2 motors in series, to avoid overheating and burning out any motors during prolonged triggering events. If one motor in a series burns out, the whole series stops working. A 2 or 3 motor alarm will also work with a 5-volt supply. To reinforce motor wires, they should be twisted together before any other work is done on them. Each motor's pair of wires should be twisted together before twisting those wires together with the other wires of a 2 or 3 motor alarm. Wire strippers should be used to remove insulation as needed before soldering, as burning the insulation off with a flame is likely to weaken the metal of the delicate wires. The motors of each alarm can be stuck to the adhesive side of a piece of Velcro tape, with the wires routed in the chosen direction and also stuck to the tape. To further reinforce the motor assembly, silicone adhesive or amazing goop can be applied around the motors and on the wires, and then the alarm sandwich completed with a piece of tape on top of the motors and wires. The Velcro side will allow the alarms to be positioned on the preferred wearable item for contacting the body in the proper locations. For headgear, alarms can be arranged around the inside of a knit cap or a headband. For wearing on a leg or arm, they can be attached to a sock wrapped around the limb and fastened with Velcro tape.